A particle of mass 8 kilograms is describing a circle with constant speed f on a smooth horizontal table. It is connected by a light inextensible string of length 3 meters to a point which is 1 meters above, directly above the center of the circle. Show that the tension string is given by T equals 3v squared. Okie dokes. Once again, parallelogram followed by ellipse. So give that 3D effect. There you go. And then you're up here, and you're across, and you're back in again. Okay. String is 3 meters. It's connected to 1 meter above it. So we have to do Pythagoras' theorem to find out r. 3 squared equals r squared plus 1 squared. R squared is going to equal 8. Root 8 equals r. Are we happy enough with that? Root 8 equals r. Now, also tells us, we'll call this angle A, just for argument's sake. So we now know that sine A is, anybody? Sine A is 1 over 3, isn't it? Or sorry, cos A is 1 over 3. And then sine A. Sine A being root 8 over 3. Okay, first bit done. Now, show that the particle will remain in contact with the table if E is less than root 8g. So, show that the tension of the string is given by... Okay, so let's work on T, guys. T goes directly up, or 8g going directly down. We also have a reaction force R acting up. On a smooth, on, keyword on, means it's in contact with the table. Okay, it's going to be hard to find. Now, what we're going to do here is T up this way, A this way, T cos A in this direction, which is 1/3 T. T sine A, which is root 8 over 3T to the right and up. Then what we're going to get is F up equals F down. And then what we have here is forces, and we forgot our 8g going downwards and our r going upwards. So r plus 1/3 t equals 8g. And then centripetal acceleration equals, is it mv squared, or what are we doing here? V squared, but looks okay, so mv squared. So root 8 over 3t ends up to be equal to ends up to be equal to 8. Is that right? 8 mv squared or 8v squared. Sorry? Oh, over r. Forgot about the r. So 8 mv squared, oh sorry, 8v squared. What's our radius, guys? Over root 8. And we want to prove that t equals 3v squared. Okay. So the root 8 multiplies by the root 8 to become 8. 8t over 3 equals 8v squared. The 8's cancel. T cross multiplies to become 3v squared. Okay, didn't think it was working for a second, but now it has. T equals 3v squared. Show that the particle will remain in contact with the table. So to remain in contact with the table, if V is less than root 8g. Now, to remain in contact with the table would mean that the R value has to be greater than 0. R is currently equal to 8g minus 1/3 t. Using this as a inequality, we're going to say that that in turn has to be greater than 0. So 8g minus 1/3, I'm going to replace in 3v squared, greater than 0. 8g minus v squared greater than 0. 8g greater than v squared. Is that what I want? And then square root both sides. Root ag greater than v. Spin it around, v less than root ag. Done. If the speed of the particle is increased to square root of 9.1 g, calculate the height at which the particle rotates above the table. Interesting. How far will it rotate above the table? Okay, so we already know that it's definitely going to be rotating above the table, right? So we know that we have our fixed point here, and we know that we have a circle that it's undergone the motion in. Look. So table is completely out of consideration right now. And our old figures don't really hold true anymore, do they? Remember at the start of the question we had what was it? We did it up here. We had 3, 1 and root 8. That angle's gone now, isn't it? Because we're just after going higher. So those old angles have no effect on the current question anymore. So what we're saying next is that it's above the table. So the table, if you will, is down here somewhere, and we have a height above the table. Now our old height was we were 1 meter above, weren't we? So that 1 meter is still going to influence the question. So from here to here in the last question was 1 meter. So we might have managed to find out what here to here is. We can just take them away and find out how far we're above the table. Okay? So what we're going to do is that's going to be t. Call this b. Call that t cos b on the way up. T sine b going into the left. Or is it 10g or 8g or what is it? 8g going down. Same system. Okay? So t cos b equals 8g. What goes up equals what goes down. And the other thing is root 9.1g. V equals root 9.1g. Okay, your centripetal force equals mv squared all over r. So we have no idea what r is right now, do we? No idea whatsoever. Okay. So we'll just leave it in terms of r. I'll leave it in terms of r for a minute. Forces up equals forces down. Okay. And okay, yeah, they use a slightly different system, but it should still work out the same way. Okay. I'm now going to use t sine b, and that's going to be equal to 8 times v squared being 9.1g all over r. What I can next do is I can isolate t in both of them. T equals 8g over cos b. T equals, I'll just leave it as 8 times 9.1 g all over r sine b. Everybody agrees that tension equals tension. 8g cos b equals HE cos B. I'm going to pause for a second. So HE cos B equals 8 times 9.1G all over R sine B. Now what we're having a problem here is the 8's will cancel, the G will cancel, and now we're going to get a sine B over cos B equals sine B over cos B equals 9.1 over R. Now, we have two variables in that equation, don't we? One equation, two variables. Beta is a variable, or B is a variable, and R is a variable, correct? So we go back up to our starting diagram. This time I'm going to get rid of the tensions, and I'm just going to focus on lengths. What's the length of the string again? Can anybody tell me the length of the string? Anybody, the length of the string is 3 meters. So I know this is 3 meters. And I know this here is R. And then by using Pythagoras' theorem, 3 squared equals R squared plus H squared. And then H squared equals 9 minus R squared. H is equal to the square root of 9 minus R squared. So that's going to be root 9 minus R squared. Now, by using this here, what I can now say is that cos B is root 9 minus R squared over 3. Actually, I should just use tan B. Tan B is going to be easier for me because I'm going to be able to do that anyway. Tan B is going to be equal to R over root 9 minus R squared. And let me show you where I'm going to use this. So this is a tough question. Bring it down. And then sine B over cos B, anybody? Tan B equals 9.1 over R. I have two equations for tan B now. So now that R over the square root of 9 minus R squared equals 9.1. 9.1 all over R, isn't it? Okay, so what we're going to do next is we're going to cross multiply the R's. So the R is in the right position, so what we're going to get is R squared equals 9.1 times square root of 9 minus R squared. Square both sides, that's R to the power of 4. That usually raises alarm bells that there's probably an easier way. This is 82.81. 9 minus R squared. Now, get this, right? We're still not done just yet. R to the power of 4 minus 82.81 R2. Sorry, plus. So I multiplied that one by that one, brought it over the other side. Multiply 9 by 82.81. 754.29. So minus 745.29 equals 0. Let R squared equal x. So this now becomes x squared plus 82.81x minus 745.29 equals 0. It's minus b time. Okay? So a equals 1, b equals 82.81 still does not mean we're wrong. C equals minus 745.29. Okay, so we're going to have to put this into an absolutely gargantuan minus b formula. So 82.81 squared minus 4 times 1 times minus 745.29 all over, sorry, all over 2. Now, the beauty about this question is x equals r squared. R squared has to be a positive number, so we're only concerned about the plus value, not the minus value. Okay, so let me know what you get out of that. I'll see if I can redeem myself here. Minus 82.81 plus square root of 82.81 squared. What's it? Minus, so let me know once you know yourself. Minus 4 times 1. 1 second. That doesn't sound good, whatever it is. Okay. Divided by 2. 8.19 is r squared. Is that right? Now, r squared equals 8.19. Square root it. However, 2.862. Now, finally, what does h equal? All the way back up here. H equals 9 minus r squared. Oh, that's handy. Wait. H equals root 9 minus r squared. H equals the square root of 9 minus 8.19. H equals the square root of 0.81. H equals, H equals 9 over 10, yeah? We're still right, because remember what we said earlier? It was a meter off the ground, yeah? Now it's 0.9 off the ground. So it was a meter off the ground, now it's 0.9 off the ground, which means we're levitating by 0.1.